The system of equations we've looked so far have always had one solution, but that may not always be the case. So today we're going to investigate some properties of linear systems. To start off with, in example 1, we have 3 different systems of equations, and I would like you to graph these lines and tell me how many solutions each one of these systems has. So pause the video, give that a try. So just a recap of what we did in the last lesson. So a reminder, a solution is where the two lines intersect, where the two lines cross. This means at that point, both lines share the same values. So in the first system, when you draw it out, I color-coded each of the lines. You have a blue one and a red one. That's how I've color-coded all these. We have one solution. They intersect at one point, and at that one point, both the x values and the y values are identical. In situation B, when graphing, the system looks like this. And we say it has no solutions or 0 solutions. Why? Because the lines don't cross each other. Right? So if they don't cross each other, that means there's at no point do they share the same x and y values. The third situation here, we say there is an infinite solution. Why? Because the two lines overlap each other. So there are many spots where they share x and y values. Actually, there's an infinite amount of spots where they have the same x and y values. So now the question becomes is, by looking at these equations, how do we determine how many solutions this system has? 1, 0, or infinite? Now the way we describe a line is by its slope and y-intercept. So we compare those, and those are the properties we look at to determine how many solutions this system has. All right? Let's start off with the infinite solution one. So in this situation, the slope of the red line is 3. The slope of the blue line is 3. So they have the same slope. The red line has a y-intercept of -2. And the B line has an intercept of -2. So if the lines have the same slope and the same intercept, they'll have infinite solutions. So the property we're looking for infinite slopes are the same, intercepts. So then maybe y-intercept are the same. What this means? This basically means that the lines are overlapping each other, and essentially they are the same line. Right? Just one is a multiple of the other, is multiplied by a constant. Right? In the second situation, let's compare what happened. Right? There were 0 solutions. Right? Comparing the slopes, they shared the same slope. Comparing the y-intercept, they had different y-intercepts. So the slopes are equal, the intercepts are different. In this situation, what we end up having is 2 parallel lines. When things are parallel, they will never cross each other. right? So in this situation, there will always be 0 solutions. All right. Okay, in the first situation here, let's compare. In the first situation, we had 1 solution. Okay, so let's compare the slopes and the intercept. All right, here we had a slope of 1, and the second line we had a slope of -1. So the slopes are different. All right. And comparing the y-intercepts, they're different as well. So in this situation, long as the slopes are different, we will have a solution. The y-intercept doesn't really matter, right? They can share the same y-intercept. In this particular case, they are different, but the y-intercept could be the same. That means they just cross at the y-axis at the exact same point. But long as the slopes are different, that means they're growing at different rates, and eventually they will cross each other. Okay. So in the last example here today, I want you to look at system A, B, and C we got here. Compare the slopes, compare the y-intercepts, then use this chart here to determine how many solutions each one of these systems has. So pause the video and give that a try. In order to compare the slopes and the intercepts, we need to rewrite the equations in slope-intercept form. So I color-coded my 2 equations. We have the blue one and the red one. So reworking the blue equation, we end up with a slope of -3/5 and a y-intercept of 3. With the red line, we got a slope of -3/5 and a y-intercept of 0, so there's no number there, right? Since the slopes are the same and the y-intercepts are different, this means we have no solutions. In this B situation here, right, we work through the blue line here. We got to rearrange it into a slope-intercept form. We find that the slope is 1/4 and the y-intercept is 3. Or sorry, that should be a 2 there. And in the red line, it's already written in slope-intercept form. We have the slope of 1/4 and the y-intercept of 2. This is an infinite solutions because the slope are the same and the y-intercepts are the same. So when you're doing these equations, and if you find the slopes to be the same, right, you have 2 possibilities. It can be. It could be either infinite solutions or 0 solutions. So you need to check the y-intercepts to see which situation is it. Is it this situation or is this situation? If the y-intercepts are the same and the slopes are the same, we have infinite solutions. But if their y-intercepts are different, then you could have 0 solutions because the lines are parallel to each other. In the last situation, we work it in the slope-intercept form. The blue line, we end up the slope of 7 and the y-intercept of -12. Right? And the red line, reworking it, we have a slope of 1/6 and the y-intercept of -5/6. Now we have one solution because the slopes are different. So as soon as you see the slopes are being different, you can just stop there. You don't need to compare the y-intercepts. Right? It is going to have one solution. And one more thing to note is, when you are comparing, we are going to have to simplify our fractions. These fractions can look like they're different numbers if they're not in the lowest terms. So keep that in mind. If you have a fraction, always double to check to see if it's in the lowest terms. So that's it for this lesson. Right? All you need to do is compare the slopes and the y-intercepts to find out how many possible solutions a system has. So give the homework questions a try and feel free to contact me if you have any questions.